Hi, I'm Mike Punske, and I am Load Test Manager at SmartBear. And today we're going to have a presentation for Mike Gualtieri, and it is 11 tips for blazing fast web, mobile, and API performance this holiday season, or how to optimize web, mobile, and API performance. So, on today's agenda, we're going to talk about a few of the performance challenges that teams face. We're going to provide 11 tips to improve performance before we get into the holiday season. We'll also talk about the next big performance challenge. And then at the very end, we're going to answer as many of your questions as possible. Just remember, this is our housekeeping slide, or what we like to call our housekeeping slide. And to let you know, you can submit your questions at any time. Just use the panel that you have from GoToWebinar. And as we get questions, we'll answer them as we're able to, and we'll also save some of those for the end and present those answers to you. We're also going to be sharing the event on Twitter. We're going to be using the hashtag blazingfast. And we're going to be providing a follow-up session at the same hashtag also following the presentation. And in case you want to go back in and take a look at the presentation after the fact, or want to share it with somebody who did not or was unable to attend, a recording of this event will be available at smartbear.com within about 24 hours after the event, if not sooner. And you'll all receive a follow-up email with instructions on how to access the recording. So before we get started, we'd like to present you with a little survey, and I mean little, and find out a little bit more about you. So if you take a look at the poll that's up on your screen, please select all that apply and let us know why you're here today. Some of the things that are up here are improving performance of your apps and development, better tests for performance in QA and production, monitor or optimize the performance of my apps in production, architect apps with performance in mind, or you're just curious about different ways to improve performance. Okay, so it's very interesting. It looks like the majority of you, by a factor of 1%, are just curious about different ways to improve performance. But then again, in second place was better testing for performance in QA and production at 65%. So that's a good thing to know. And now I would like to present Mike Gualtieri, Principal Analyst at Forrester. Mike has more than 25 years of experience in the industry, helping firms architect, design, and develop mission-critical applications in e-commerce, insurance, banking, travel and hospitality, manufacturing, healthcare, and scientific research for organizations including NASA, eBay, Bank of America, Liberty Mutual, Nielsen, EMC, and others. Mike has written thousands of lines of code, managed development teams, and consulted with dozens of technology firms on product, marketing, and R&D strategy. So, go ahead, Mike.
Thank you, Mike, and welcome, everyone. My name is Mike Gualtieri, as Mike said, and I'm a Principal Analyst here at Forrester, and I'm in our application development team. So my research focuses on most things application development, and one of those areas is what we call blazing fast website performance. And so I'm going to talk to you about 11 tips for blazing fast performance. Now, we've set this in the holiday season because there's a lot of high-profile things that can happen, especially in e-commerce sites surrounding Cyber Monday and that whole holiday shopping season. Now, originally they asked me to do 10 tips, and I just couldn't do it. I had to add an 11th. So you probably got the email about this session that it's 10 tips. Well, that's why it's 11, because I needed 11. I couldn't do it in 10. So first, let's look at some data. Let's look at some of the outlook for the holiday season and what we can expect, and what does it really mean for traffic to increase at that time. Well, you can see here that shopping definitely ramps up starting on Thanksgiving and then rapidly increases. Traditionally, Black Friday is more of the let's go to the store, let's go to the Rentham outlet mall or wherever you happen to be. And then Cyber Monday is where the online really ramps up. And one of the reasons for that is because people are shopping at work. I know that I do most of my shopping at work. Hope my boss isn't listening to this. But it does account for about 50% of all the Cyber Monday spending. And for retailers, for online retailers, e-commerce retailers, this entire holiday season, not just Cyber Monday, but the entire holiday season can make up 40% of the retailer's online revenue. So, you know, for just a 6-week period, that's a ton of revenue. And you don't want anything to prevent you from getting that revenue, especially websites that people abandon because they're too slow or because they can't handle the load and they go down. And there's, you know, a number of high-profile situations that always seem to happen on Cyber Monday. Newegg.com, a lot of you probably know Newegg, computer stuff. Nordstrom, Target all had some problems last Cyber Monday. So we also know that shoppers are shifting more of their wallet share to online during the holidays. So they're going to the store, and increasingly the money they have to spend, they're spending online. So what this really means is that it's just going to increase. So it's going to continue to be a challenge to handle sort of the peak traffic that's going to continue to increase. And but it's not just about e-commerce. It's not just about the store, because you might be saying, well, you know, I don't have an e-commerce site, but you may have another site. And the thing is, web influence sales are much bigger than online sales in themselves. So even if you're not selling something directly online, your traffic may increase just because people are searching for things and looking for things and trying to get information. Now, of course, we're talking about online holiday shopping, but performance is important at any time as well. It just, the problem gets exacerbated during this holiday season. So the bottom line here is that performance has a direct impact on revenue, and we don't want to let performance, availability, or scalability be the reason. Okay? And as technical people, as developers or operations people, as testing people, it's pretty much our responsibility to make the site perform, to be available, and to be scalable. So there's also online, there's so many other choices. So online shoppers, they have pretty much unlimited shopping choices, and they know it. So, you know, if a site is not performing or it's not performing well, boom, they can just go to another site and buy from that site. So it's not like they're going to stick around, per se. So it's critical that that performance be as fast as possible. So that's what we're here to answer. How can we avoid an embarrassing online disaster? And I'm going to go through now 11 tips to prevent that. And you'll see that there's a mix of these tips that have to do with development and infrastructure and a bunch of other stuff. But let me start first with Vitruvius, who is the 1st century Roman architect and author of a brilliant 10-volume book called the Architectura. And he defined architecture broadly as having 3 qualities: firmitas, utilitas, and venustas. Does anyone take Latin, or can you figure out what those are? No, it's pretty easy. Firmitas means it's strong. Utilitas, the function, and venustas, that's like, you know, Venus, that's beauty. So in software, though, we have 7 qualities that we think are important. So in architecture, there's 3, and in software, there's 7. Now, I'm not going to go through all 7 of these, but I am going to highlight 3 of them that are critical, which is performance and availability and scalability, and that's what these 11 tips will cover. Now, let me distinguish between these 3. Performance is the latency. It's the speed. It's the response time that the user experiences. Availability is whether the site is up or not. So, I guess if your site goes down, you have 0 performance, right? And then scalability is the ability to handle an increasing, in some cases, decreasing load. Decreasing load is to optimize the use of resources, but in the holiday season, we're concerned with the increasing load. So a lot of people just say, oh, scalability, but scalability is really separate from performance. Obviously, all of these things are interrelated. So all of these tips center around performance, availability, and scalability. So performance isn't just about one thing, and I think of it in 3 layers. There's the channels, where the clients access it, the web, the mobile, the APIs, right? Because increasingly, shopping channels are exposed through APIs. And even if you don't have your front end yourself, you may have your APIs exposed, and those have to perform. There's the thing you don't really control, which is the internet and third-party services you may be using inside your website. And then there's your own application and your own infrastructure that's running largely on the back end, whether it's hosted or on-prem or in the cloud. That's your code. That's your infrastructure that you control. So there's things here that you control, and there's things here that you don't control. But there's techniques that you can use to mitigate the risks of things you don't control, and techniques that you can do for the things that you do control. So let's look at those tips to keep Melissa shopping. First one is to benchmark. And I can't tell you how shocked I am, how many people talk to me, and I ask them, well, how much, what's your peak load? Many don't know that. Or what's your performance? They don't test it. They don't benchmark it. So before you start any performance improvement program, you have to know where you're starting from. So you have to test to benchmark the capacity, performance of just one transaction, but performance at load. And you need to find the breaking point. You need to know if we get 10,000 people, if we get 500,000 people, the site is going to break. Now, break could mean that it's just locked up, it's not available, or it could mean that performance is so slow that the site is virtually unusable. So it might be a threshold. So instead of a page loading, in 2 seconds or 1.5 seconds, it loads in 12 seconds. You may consider that to be the breaking point. But bottom line is, you absolutely have to test to create a benchmark so you know where you're beginning from. Because how else will you know you're going to improve? And you have to test from the customer's point of view. You can't just test like one server, your database server. So you have to create scripts of maybe your shopping flow, searching for a product, putting in a shopping cart, checkout process, payment. So you have to script that and play that back and run it at increasing loads and then measure the performance. And you have to have multiple scenarios, and one important one is to find that breaking point and to find what the performance is at different loads. So that's the first one. The other thing is people often ask, well, how fast should it be? Should it be 4 seconds? There used to be something called the 4-second rule and the 2-second rule. And what those rules said is it was like, well, if your page loads less than 4 seconds, then shoppers will start to abandon. And then they revised it to 2 seconds. But the reality is you have to benchmark it against your competitors. You have to find out, if you're in the retail business, what are your competitors' load times? So you have to, so the answer to how fast should your page load, it should load as fast or within a tolerance of your competitors. And a good example of this is travel sites. Travel sites were really slow And then when one person boosts the performance, then it's kind of like a performance war. Then there's an expectation that it's faster and faster and faster. So do your own benchmark, but also compare that to benchmarks against your competitors. The second tip is to run Google PageSpeed. How many of you are aware of Google PageSpeed? I find that, I don't know, I'd say maybe 25% when I tell people about this have heard of it. But Google PageSpeed, you can just Google PageSpeed, and it'll come up. And what it is, it's a site that has a list of best practices that Google is constantly revising. And all of these best practices have to do with how the HTML and the JavaScript and the CSS and how your site within the browser reacts to the server. So there's a way to optimize the HTML, and it will do a quick test against those best practices. For example, if your site loads 30 images, it may say, hey, that's too many images. It would be helpful if you made that a sprite, for example. So the reason I put this as number 2 is because sometimes the fastest way to increase the performance of your site is to run this, find a few of the best practices. You might be able to see here there's some combine images into CSS sprites, leverage browser caching. So I encourage you all to go run this against your site or against any site for that matter and familiarize yourself with this tool, because this will tell you high priorities, and it will be like, boom, I can just do this inside my HTML, and I will get a performance boost. So that's why that's number 2. Now the third thing is what is near and dear to my heart, because this is the only tip I used to follow back in the day, which is the code. Because if you're a programmer, you know, you're obsessed with your code, and you want that to be as efficient and performant as possible. And that's why the third tip is to know your code, is to test your code to eliminate bugs, because bugs can be performance bugs. And so it's good in your bug tracking system to track those as performance bugs, or they can also destabilize your app, or even shut it down, or shut performance down, and that's an availability consideration. So availability, not from the whole system's down, but maybe the availability of a certain key function. So one way to do this is have a fun time. And the fun time is peer code reviews. And these are great, because everyone loves to talk about their code and explain, you know, the decisions you made. And then everyone else reviewing it loves to point out, you know, what you did wrong. But the end result is better code. And trying to head off bugs or performance sapping things that will cause performance to go down. Now, the usual culprit in this is always like database connections, right, and connections to data. So that's kind of where the low-hanging fruit usually exists when it comes to code. But there's performance profiling tools you can use to quickly identify loops or areas of the code that could be rewritten to be faster. And the thing is, once you change this code, you've got to rerun those benchmarks, which is tip 1. And you should have an automated way to run those tests. We'll get into that a little bit later. So tip 4, which isn't something you can control as a developer or necessarily a tester, but it is the cause of many sites going down, and that is hackers. They can launch what's known as DDoS attacks, or distributed denial of service attacks. So you have to have a solution for DDoS. There are some outside services from firms like Akamai that can examine your traffic and then spill off attacks like this. I was involved in, well, no, I wasn't involved in it. I didn't do this. But all right, let me just tell you the story. So the U.S. House of Representatives, I don't know if you remember a few years ago, Obama made a speech to Congress about the health care. And then there was that one guy who like shouted out, "You lie," or something like that. Remember that? It's a few years ago. What happened the next day is that the U.S. House of Representatives website, the .gov website, it basically choked. It went down. It was a combination that it was hacked because, I don't know, someone just hacked the site, but it was also a lot of people running traffic against the site saying, hey, who is this guy who stood up and said this? Well, anyway, the site went down, and the Speaker of the House at the time said, look, we're the U.S. government. Our congressional site can't go down. How could this happen? And it was a combination of these things. Part of it was hackers, but part of it was they weren't, and this is another tip I'll get to, they weren't monitoring the site. They didn't know that it was down. Anyway, you have to have a strategy to handle DDoS attacks. Fifth is infrastructure. I'm not going to spend too much time on this, but you have to have redundant infrastructure to achieve high availability. This is pretty obvious, but what's often missed is there's different components. So people, I can't believe how many people say, well, yeah, I have multiple web servers, but then there's one database server. And sure, that database server may be hardened, but there's a lot of things that can happen. So, and there's a lot of different components. So some sort of redundancy is needed in that infrastructure. So this is merely to examine all the infrastructure components and make sure that they're duplicated. Oh, you think cloud's the solution? Well, ask Netflix and some other people who are on Amazon. Okay, and this isn't a diss at Amazon, because Amazon is cool and Amazon Cloud's cool, but it underscores the point that you can't just assume that you have infrastructure redundancy. So you have to have that. So that's tip 5. Oh, this was meant to be a quiz. Well, I'm going to quiz you. Don't look at the slide. What does 5 nines mean? Because you know how people like to, especially like operations guys, they like to throw around 5 nines or 4 nines. And I always wonder, well, do you actually know what that means? Well, 5 nines means that your downtime per year can be 5.26 minutes. That's pretty hard to achieve, right? And you can see some of the other, what it means to be down 98%, 7.3 days, or 99.5%. Would you be proud if you had 99.5% downtime a year? I would, because that's pretty good, unless that 1.83 days was on Cyber Monday. Then you'd be in trouble. So you really have to think about what is the likelihood of a particular downtime occurring on that day. And that's why we're kind of focusing on these peak periods. The 6th tip is to cache. And caching is used a ton at many different levels to reduce internet latency. And there's really 3 levels of caching that I'll discuss. And it's roughly goes with that 3 levels of caching I talked about, 3 levels of architecture I talked about in the beginning. But the user's distance from the content actually matters. So look at this example here. So you've got a web server in Tampa, Florida, and you have a user who's accessing that web site from Orlando. Well, the network latency, that is the internet latency itself, is 1.6 milliseconds. That's cool, right? So every request to that server, costs 1.6 milliseconds. Now you might think, well, that's not a lot, but if your page is loading like 30 things, you have to multiply that by 30. You follow me? But now let's go down. Say we're in Pennsylvania, and we access that server in Tampa. It goes to 16 milliseconds. And then across continent, so say you had a server in New Jersey, and people are accessing content in San Diego, it goes to 48 milliseconds, and multi-content 96 milliseconds. So there is lots of internet latency there, and this really adds up. And that's why companies such as Akamai, might have heard of Limelight, may have heard of Edgecast, and some of the telecoms have what's known as a CDN service, a content delivery network. And what they do is they just forward cache that content. So they cache a lot of the static content. So again, if you have that server in New Jersey, they have servers in San Diego, and a lot of the static content will be served locally, while your dynamic content will be served remotely. So that's what edge caching is, or a content delivery network. The other fast way, though, caching is in the browser. And remember tip 2, Google PageSpeed? You can run that, and one of the things that's going to test is it's going to test if you're caching content. I mean, you guys know, you have a 60K JavaScript file. You're not going to want to load that every single time, right? You're going to want to cache that in the page. So that's the fastest way to serve content to the user is through that browser cache for static elements. And most sites are dynamic, but there are still a lot of static elements there. And then finally, a server cache, right? This is usually on the database cache. Imagine a site like Facebook where every page is really personalized, right? There's a lot of personalized stuff like that. It has to go to the database. No, they have a huge farm of in-memory servers that assemble your page as page fragments so that they can be served up really, really quickly. So there's many different ways of caching on the back end as well. So tip 7 really has to do with mobile, because the other thing we know is that mobile shopping, and especially tablet shopping, is also a reality here. And it makes testing much more complicated. So you have to test your site in multiple browsers, in multiple versions, and multiple OS versions to optimize the performance. Because you cannot just test in one browser. You might test a site in Google Chrome and Firefox, and you can have 2 or 3 second differences in just those different versions. Here's a classic inquiry I get from clients. Oh, a vice president of such and such is complaining that our website is really, really slow. But when we test it, it's lightning fast. And it turns out that, yes, they're using some older version of Firefox or an older version of IE. So you have to test in these multiple versions. Here's some mobile homepage performance differences. And this has less to do with the version than it has to do with the bandwidth, right? So, I mean, you can see here that a 3G network takes, this page takes 8.18 seconds versus 4G 6 seconds. Gee, you'd think, the way they talk about 4G, it would be, a half a second. But there are big differences here, and you have to understand these differences to understand what the customer's experience is going to be. The eighth tip is really, really scary. It's third-party APIs. And the reason it's scary is you don't control it, right? And what am I talking about when I'm talking about third-party APIs? I'm talking about the shopping cart services, the rating services, the ad services, the other components that you use and you integrate on the glass in your website. You may call these APIs from the server as well, but many people think, oh, well, I have an SLA with them, so I'm cool. But if that SLA fails on Cyber Monday, for example, you can go yell at them and say that they failed the SLA, but your customers are still unhappy. So you can't be held hostage by these third-party applications. And so how do you do that? It can be pretty complicated. Here's one example. Battery Junction, small e-commerce provider, but big in what they do, flashlights and batteries. That site uses Yahoo Carts, and it uses many other third-party components. Some sites use Google Maps. So this is just their social plugins where you have the code. So you know what I'm talking about, right? Third-party APIs that you integrate into your site. We have to choose these wisely, okay? The first thing is, do you even know all the third-party components you're using? Say you're a developer and you're developing these pages, but you also have a web content management system. There could be some people in marketing inserting code that makes call-outs to third-party apps. You may not even know it. So you have to know what your components are. So you have to take inventory of that. And you have to ask everyone, e-commerce professionals, marketing, everyone. And then you have to do a bit of due diligence on each one of these component providers. Is it an established firm like Yahoo Shopping Cart, Google Analytics, Google Maps? Is it a startup that hasn't gained momentum? Did they just start the company in July? Maybe they're not prepared for Cyber Monday. have they published usage, outage, and performance data for components? This is a wonderful trend. Like Twitter, for example, produces that data, so you can analyze it. You can see what the outages actually were. Do your competitors actually use those components? Because that might be a good sign and a good way to know if it's a cool component. And if you choose to be an early adopter of that component to gain a competitive advantage, you have to mitigate those risks. So what I suggest is that you assign a confidence level of 1 to 5 to each one of these components and their service level agreements. I thought I had another slide after that, but yeah, so you assign a confidence level, and then you have to come up with a mitigation strategy on each. I think I'm missing a slide on that mitigation strategy, but we'll just go on. I think you understand third-party components. And the third-party components might not just go down, but they may also slow you down as well, because they may not handle. And I have a little story on that, too. It was a large Midwest retailer. I mean, big brick and mortar, but they had an online. And during this holiday season, they had a third-party payment service. And anyway, they focused all of their effort on keeping their infrastructure and their e-commerce system up, and they did a great job. It didn't go down, but the bottleneck was actually the payment provider. So you have to identify, eliminate, and mitigate all of those architectural bottlenecks, not just your own, but potentially the third party. So this is the confidence level I was talking about. You assign every component in your architecture a confidence level. Okay, so 1 to 5. 5 means the SLA exceeds your requirements, and it has an insignificant history of breaches. So this is ideal. You can't always find 5s. Okay, so sometimes it's going to be okay to use one that's a 1 or a 2, but you have to have a mitigation strategy. And here's how you decide on a mitigation strategy. For each component that's used in your website, choose one of these mitigation strategies that's on the next slide after you choose a failure condition. So what if it has a functionality problem or a bug? If you're using a third-party component, they may release a new version of the code, right? That happens all the time, and that could break your site. So what are you going to do if there's a bug in that component? Second failure condition is availability. What if the component is simply not responding to requests? That's what happened to this retailer when they started using the payment service. Or what if the component slows down? It's just simply taking too long. And what if it can't handle the volume, scalability? So unfortunately, you need a strategy for each of these 4. So some of the potential strategies here are none. You've just decided that that risk is low, or the cost to mitigate the risk is too high. Okay, what's really important here? Like, for example, what if Google Analytics goes down like it did several years ago? That actually happened to Forrester Research. Our site went down. Why did our site go down? It was like Google Analytics was down. And, could we have built something in? Yes. Did we? No, because there's certain expectations of certain components that don't go down. But you have to assess that risk for yourself. Code around fault tolerance. You can write code that will detect a component failure, or you can use a monitoring service to detect a component failure, and then find some workaround. So you can imagine that e-commerce situation where you detect that the payment service is down, you gather the information, but then confirm the payment later. Okay, another idea there is, say you're using a third-party rating and review service, and that goes down. You could simply not display that on the page, for example. The other strategy is to have a completely alternate website. Maybe you're doing some A/B testing. You could just go to B for everything. And the other thing is you could swap out. If a component fails, you could quickly code and swap out one. I mean, that's probably the worst case scenario, but it's a strategy nonetheless. Now, the 10th tip is that once you do all of these performance boosting activities, benchmarking, caching, and everything else, then you have to continuously monitor from your customer's point of view. And this is where you have to use some third-party monitoring service, which is constantly on a regular basis. It could be every 30 seconds, every 5 minutes, whatever makes sense, to run scripts against your site to measure the performance and then to alert you when there's a problem, because you're going to have to react to whatever problems occur. And when you measure that performance from the customer's point of view, it's real important that you're measuring the perceived performance, okay? So I'm not sure if you're all familiar with this concept of above the fold in a website. So if you look here at the Walmart, the full page, this is loading the entire page, in this test took 3.89 seconds, okay? And then it took 2.17 seconds, but above the fold took 1.4 seconds. So the user's perception is that the entire page loaded in 1.4 seconds, okay, above the fold. That's when they can see everything. That's when they can start interacting. And to do that requires, it's how you output the HTML and the JavaScript and the CSS. And you have to monitor from what that user's perspective, not from your network, not from the browser, but from what the user actually sees. So the best practice here is also to baseline the performance metrics with frequent reporting so that you know the ups and downs, and you'll start to get an idea of, oh, I get a lot of weekend traffic, I get daily traffic. It's important to test it after you do a new release of software. So in addition to continuously monitoring, whenever you do a new release, and know what elements of your infrastructure are actually affecting that performance. So that's the next step. Once you know how fast it is from the user's performance, what are the elements affecting it? And really the 9 prior tips all have an impact on that. And then finally, problems do occur, despite the best laid plans. And there has to be a team and contingency plans in place to react quickly to whatever issue arises. So many teams are on call, but part of the problem with this on-call strategy is that it just means everyone's going to get on a conference call, and then they're going to start talking about it like they have no plans, they have no scenarios. So you have to create these failure scenarios, decide who can react to those failure scenarios, and what they're going to do. And this doesn't just include developers or infrastructure and ops. It also includes the e-commerce professionals and the marketing professionals, because there may be some steps they have to take to mitigate the fallout of a site that's down or performance that's lower. So you have to react quickly to that. And here's some data that shows only 6 out of every 20 e-business leaders even know that what their disaster recovery strategy is. So it is a problem. So these are the 11 tips. I'm not going to go through them again, but you can access this from the site. And the next big performance challenge is going to be in the cloud. I indicated that there are third-party components and things that aren't in your control are the biggest challenge. So the cloud has a promise to make performance, scale, and availability easier in some ways, but it can also be more challenging because you're going to have to architect your systems very differently. You're going to have to architect them to be elastic and fault tolerant. And many traditional e-commerce systems or web applications in general are not. So that's going to be the next big performance challenge. Cloud adoption is accelerating, but so we know it's coming. But most companies aren't using it, and few of the clouds have significant traction. You can see here that Amazon is still the king, but there's really no clear second place at this point. So Amazon is still the king on this one. So the whole point of the blazing fast techniques and the whole point of these tips and performance is to keep your customers shopping, to keep them happy, to make them loyal, so they'll keep coming back and telling their friends. And Cyber Monday is only 4 months and 1 day away from today, and Christmas is 5 months. So this period's coming up. So it's actually, most of these tips, it's not too late to actually, benchmark, do the testing, run Google PageSpeed. Caching may be like a challenge if you don't already have it, but most of those tips are completely doable within this time frame. So I hope you found that helpful, and I'm going to pass it back to Mike.
Okay, thank you, Mike. Hi, everybody. Just want to remind you that we're still taking questions, and we're going to have Q&A in just a few moments. So if you have any questions you'd like to have Mike answer, please get those over to us, and we'll present them very soon. So part of this slide here points out that here at SmartBear, we have a number of tools that address a lot of the issues that you'll come across in performance, including AQTime Pro, which profiles performance, memory, and resource debugging. Also Load UI Pro to load test APIs and web services. Load Complete for load, stress, and performance of web applications. Alert Site division of SmartBear also does website monitoring. So we monitor both performance as well as availability of your websites and their components. And that includes API monitoring, and also Alert Site provides mobile monitoring as well. Next slide. Just another reminder that you can still submit your questions, and I will present some of the questions that we already have to Mike now. So one of the first questions that came in, Mike, was what is the return on investment of web performance monitoring?
Well, I think the way the answer to that is how you calculate what the cost is of not doing it, and that's going to be different for every situation. So it's really easy to actually look at your past e-commerce sales data. So I'm going to talk about first like availability, like when people can't do anything, and then we'll back into performance. So say you take a month period and a daily period of what those e-commerce sales are, and then just create a model in Excel that says, all right, well, what if I am down at any, what if my site is down at any one of these particular times? And then, boom, you're going to get a calculation. It's kind of an oversimplified calculation because it's going to assume that, if it's down for an hour, it's going to come right back up and you're going to get that same amount of shopping. So it's a little bit of a simplified model, but it's a good starting point. And then what you do is then you create an abandonment figure. So you create a cell in that Excel spreadsheet that says abandonment rate next to performance. So if the performance goes down by 30%, it's 30% slower, I'm going to lose, say, 10% of the customers or 5%. I'm not saying those are the figures you should use, but that's how you can model it. And then you can do several different scenarios for your site about what it will cost, what that abandonment rate will actually cost you. So that's the starting point. Then what you have to do is you actually have to get data for what that abandonment rate might be. Now, if you're lucky, you can use past performance data to actually model that. You can actually see, like, if performance went down, the number of customers, and so you can use actual numbers. And this is a key to doing ongoing monitoring. If you're going to continue to monitor, you're going to have that data available. You take your monitoring data, your performance monitoring data from your external monitoring site, you marry it with the sales data and your weblog data, and now you have a data set that you can work with to calculate that. But if you don't have all of that, or you don't have all that right away. You can do what I said. You can do a simplified model and look at multiple scenarios.
Okay. Next question that came in was how much or how close of a relationship is there between performance and functionality?
That's one of my favorite anecdotes, is that many customers, consumers using a website will say it is slow. And this is very frustrating to a lot of technical people, because the technical people will run the test and they'll say, oh, well, the pages load, sub-second, and the transitions to new pages are sub-second, and they're still saying it's slow. And the reason why they're saying it's slow is often not because of the performance. It is fast in terms of loading pages, but the usability, how it's designed, it has a poor design. So, for example, a user who has to click on 4 items, they have to do a 4-step buy process versus a 1-step or a 2-step buy process. The 4-step process with all these clicks, the consumer will say it's slow. So you see, they're using the word slow not to describe like the actual technical performance of the rendering, but they're using it to describe the user interface. This is really important for technical people to understand so they don't go crazy, right? So they can go back to the e-commerce people or the marketing people or the executives and say, well, let's look at that user experience, because the way that site is designed may be the culprit versus the actual performance.
Okay. Thank you, Mike. Another question that came in was, how can we test distance dependency of performance? Normally, we'll be sitting in one place to test an application.
Oh, yeah. I mean, you have to use an external monitoring service, just like Alert Site, that will test from different locations, and that'll just give you actuals. That'll give you actual performance from Seattle, Washington versus Florida versus Texas versus London.
Or South America.
Or South America, yeah, wherever it is. And then you'll actually see that actual data. And if you already have a CDN, like an Akamai, you'll still notice some differences. But if you don't have a CDN, you'll notice a huge differences in that internet latency.
Exactly. Okay. Another one that came in was, how do you do a benchmark on your production environment without actually taking down your production environment?
Well, you should actually be benchmarking your production environment constantly. That's continuous monitoring. So using an external monitoring service is a best practice to monitor for performance degradation from the user standpoint, where you'll get alerts to know that something's happening and you have to investigate. But at the same time it's doing that on a periodic basis, it's also storing and tracking this data. So you're going to have you're going to have a lot of data depending upon how frequently you monitor and what you monitor. But you can set that all up on a schedule, and then you can download and then use that data, analyze it to figure out the relationship, for example, between the number of users and performance. But you also want to load test too. You want to load test periodically as well, and you can load test against production data as long as you ramp it up and you have workflows into test accounts. It can be more complicated than that, but the simple answer is the monitoring. The continuous monitoring is a continuous test.
Okay, thank you. One other question that came in that's a little bit more complicated is, in what way must a cloud-based system actually be elastic? What contingencies can be set to alleviate cloud performance failures?
Well, the failures that we've seen, I mean, there's different levels up there. The failures that we've seen that have made the news have been data center failures. Like the Amazon data center, lightning, I think struck it and it was down for a little bit. And what Amazon says, and they're right, is that you can deploy in multiple data centers. They have 2 data centers. But what's not so easy is that your software has to be architected to handle that. So it's real easy to just reroute web servers. But what about the data? It's not so easy necessarily to reroute the data if you can't access the data. And all these things are becoming interdependent. So you have to design for fault tolerance. And it really goes back to what I said about identifying all the architectural components and then creating a mitigation strategy. So Elastic is about automatically provisioning resources to handle load, but it's also about fault tolerance. So it is a more complicated question, but my answer is kind of the parameters of what you have to look at.
Okay. Here's one. For any application, who fixes the minimum system requirements? Is this done by testers, developers, or somebody else?
It's done by somebody else, and that somebody else is the data. So someone can't just arbitrarily say someone doesn't need to arbitrarily say this is the minimum system requirements. You can test it. I mean, by system requirements, I assume you mean the browser client and maybe the mobile client. The point is, you need to test it against all of those versions on different platforms, and then the testing will tell you, this is not going to work on IE6, or we're not going to go to IE6. Now, if there's some sort of business requirement that says it must work on there, and then testing says, well, our current won't, well, then there's a business decision because there's a cost associated with making it work. But I love data because data can give us shortcuts to helping make some decisions exactly like that.
Okay. Let's see. We have time for a few more questions. Is it good to use a fancy UI component over a simple one provided by the UI frameworks like ASP.NET Controls?
Can you ask that again, because I was fixated on the word fancy.
Okay. So is it better to use, let's drop the word fancy. Is it better to use a different UI component than the simple ones provided by the UI frameworks like ASP.NET Controls?
I don't know what you mean by simple. I mean, I wouldn't avoid the ASP.NET Controls per se. There's a balance between functionality and performance. So I really don't know how to answer that question. I wouldn't say that there's a simple rule there. I mean, I'm not a big fan of the keep it simple, because in reality things are complicated, and it's very and if we're talking about e-commerce sites, it's very competitive, and so sometimes a fancy tool that lets you try on the clothing or view something from multiple angles, that has trade-offs. That can be slow to load, it can be sluggish to use, it can be hard to support on multiple platforms, but on the other hand, it can provide a differentiated shopping experience. So I think it's a little more complicated than I can answer based upon just one control, if you know what I mean.
Right. I just got a follow-up from the person that submitted that question.
Mm-hmm.
And according to him, fancy means third-party components which might impact performance of page loads.
Oh, yeah. Ooh, yeah. It's really the same answer. Third-party components are great. I saw some recent data. I can't remember where I saw it, but the average e-commerce site makes calls out to 9 or 10 different domains. So the use of third-party components is rampant. And it's easy to understand why. It gives you immediate functionality. And it's not just the GUI visual component, but there's a lot behind some of this functionality. You know, there's links to social media, or there's different shopping experience, or catalogs, or you know, I mean, just look at the number of third-party APIs out there. There's a huge number of them. So you can't make a rule. My advice is you can't make a rule that says we're not going to use third-party components because there's just too much value there, and it can help you differentiate. It can help you get features faster, but you have to go through that exercise that I showed on the bottlenecks, where you have to assign a confidence level to those components, and then you have to support each of those 4 failure scenarios. You have to have a mitigation strategy. So is it costly? Is it a bit scary? Yes, but there's upsides to it too. So you can't just say no to it. Anyway.
Okay. And the final one for right now, for a good test of an application, is it good to have different people doing development and testing, or is it a good idea for the developer to do both?
Well, I have a very controversial blog post out about that, well, anyway, there's definitely a need to have separate testing, but, you know, sometimes developers use testers as debuggers, right? It's like you're going to be, you don't have to, you know, you're trying to meet the deadline, and you could be a little, oh, yeah, that probably works. I'll just throw it over the wall. And then the testers become debuggers. And then the developers don't get, you know, it's just like a bug, you know, but no one goes in there and says, that's a bug you could have avoided, don't do it again. So I think there has to be some responsibility for the developers for their own testing, and there has to be some tracking mechanism that says who has more bugs, but even that's fraught with, you know, with some problems. So I think more of the burden of testing can be on developers if they have the right tools. But I think you also need sort of that QA safety net as well.
Okay. Thank you very much, Mike. This was a great presentation. And I just want to point out to everybody that we've gotten a lot of questions over the past 20 minutes or so about whether or not this session was recorded, and if so, where the download will be available from. And our plan is to have that recording available within the next 24 to 48 hours. We will send out an email to everybody who registered and let you know where you can download that from. And I want to thank everybody for attending today, and thank you, Mike, for a great presentation. And you can contact us if you have any further questions.
Thanks, everyone.
Thanks, everyone.